alive have been pulled out, and at this stage a lot of the rescue effort is just to see if there are any more victims under the rubble.
L'Aquila itself is a lively cottage town consisting of narrow streets lined with Baroque and Renaissance buildings and churches. L'Aquila has been a center for earthquake disasters and has been affected several times. The city was struck by earthquakes on December 3rd, 1315, January 22nd, 1349, 1452, 1461, 1501, 1646. And on February 3rd, 1703, a major earthquake struck the town. More than 3,000 people died, and almost all the churches collapsed. The Confraternita del Suffragio, which was a 17th century church, also collapsed during this time, and in 1716 was replaced by the Santa Maria del Fragio. In 1706, the earthquake struck the town as well, and in 1786, a major earthquake killed 6,000 people. In June 26 of 1958, another earthquake struck, and the last earthquake, which hit in April of 2009, with a Richter scale of 6.3, collapsed the dome of Santa Maria. These were our initial concept designs. We wanted to use rotary motion to get the monument to move throughout the day and when it sensed earthquakes. The idea was that it would provide different forms throughout the day and even possibly provide shelter for vagabonds. We initially struck this idea because we wanted to actually ground our project into a site and didn't think that this was a good idea. So we added sensors and motors, and as you can see, the project got a little bulky. We were trying to take the dome and piece it into 5 parts, but this wasn't really working for us.
However, we rethought our design based on Da Vinci Scott Brown's Benjamin Franklin's ghost structures at Philadelphia. Our spiral dome now is actually the ghost of the dome of Santa Maria that was destroyed. As you can see, the initial state of the dome is as shown, and it's raised. It's a raised spiral, and it's raised upwards. And when there is a vibration, it's detected, and the dome collapses inwards into a cup-like shape. The lights that you see are actually on the plan of the dome at the ground level, which also indicates the markings and the engravings commemorating the earthquakes that have affected the town over the years. As you can see, once the earthquake stabilizes, the spiral would raise upwards, and the lights would become stable in the outer circle. On a given day, which is commemorating one of the earthquakes that had occurred in the place, the spiral would actually start downwards and then move upwards to form the dome, and the outer lights will go stable to indicate the end of the earthquake on that particular special day. This shows the hardware that we used, which basically consists of all the mechanical and the electronic components. Essentially, we use 2 continuous servo motors, one for pulling up the spiral and one for pulling down the spiral. And we used 15 LEDs in 3 concentric circles on the plan of the dome. We also used 3 Arduinos, one for controlling the 2 motors and 2 for controlling the LEDs. And we used a Wii Nunchuck Nintendo, which senses the vibrations with its accelerometers. The ground plan of the building is seen. It consists of 3 concentric circles with lights. Small figures of people are shown for scale. Initially, during the initial state of the dome, the innermost circle of lights are glowing in the form of running lights. Once the earthquake happens, as sensed by the Wii chuck, the second row of lights start glowing. After some time, when the vibrations subside, as sensed once again by the Wii chuck, the outermost circle of lights are glowing stable, indicating the end of the earthquake. You can also see on the plan on the floor certain engravings which show the important dates along with the Richter scale recordings of the important earthquakes that occurred over history.